So now you understand a lot about lists. You can make, process, and sort a list in Scratch. But, of course, we know that the APCSP test doesn't cover Scratch. Instead, you need to understand the College Board's pseudocode system and how lists might show up on the exam. Let's take a look at a couple of practice problems. Let's take a look at a couple of examples of how you might see lists on the APCSP exam. Here's an example of some pseudocode. Let's just walk through that very quickly. You can see that this is going to repeat 5 times, iteration of 5. All right, and that inside that iteration, all of these things inside are going to be included each time through the loop. So the first thing that's going to happen is that name is going to be assigned a value of whatever our user has typed as input. Okay, so there's been a question asked and the user types an answer. Whatever the answer is going to be assigned to the variable called name. All right, you are going to have to follow that variable as it goes through this loop. All right, so the first thing you're going to check is to see, is it true that whatever the user just typed that is now stored as name is equal to item 1 in the list called player? Then do this right here, display the length of player. I set up kind of a table so that we could step through these values as they change each iteration, and I highly recommend that you do this, that you find somewhere to write some notes, make a little table or some sort of way for yourself to follow the different variables and items in the list through the iterations when you take the test. I think it's really important. All right, so anyways, right now length of player, that list, is 0. It's empty. And then another important word shows up if the name is not equal to item 1 of player. And that is, if it's not, we are going to append, which is a fancy word for add, but add means something totally different mathematically, so we have to use a different word. We can't say add, we use the word append. We're going to append to the list called player whatever name currently is. All right, so the first item there is the name of the list. The second item is what is the name of the variable that's going to get added. All right, and then of course we would display the length of the list once that has happened, okay? Because if we're appending something, now the length of the list has changed by 1, okay? Let's follow this code through and let's see what happens. We are going to add in a series of names, all right? And the first name is going to be Sam. The second name is going to be Sam, our second player. Our third name is going to be David. How about just Dave? And then Dave is also going to be the fourth player. And then Sam's going to come on back and play. All right, so there's going to be a list of 5 names eventually, or there are going to be 5 names entered. And we want to find out what exactly is going to happen here. All right, so on the first time through the loop, input is Sam. All right, so we set name variable to Sam. All right, and the question is, does that name equal the value at item 1 in the list? First time through, that is not going to happen. All right, so we're going to move to the else. All right, so it is going to append player name Sam to the list. All right, so I'm just going to see if I'm going to do all caps. Sam, I am. All right, so we've appended the name Sam to the list, and it says now we're going to display what the length of the list is. Well, the length of the list is 1. Okay, so that's our first time through the iteration. Next time, Sam is player 2 also, so second time through this loop, the input is also Sam. All right, so we set name to Sam again. And then we check to see if that name Sam is equal to whatever is at item 1 of player. Okay, this time it is. Okay, so now we want to display the length of player again. Well, what is the length of player? It's still 1. There's only 1 name in that list. All right, so it's still 1. All right, and then we ignore the else. That doesn't happen. All right, in this selection. All right, third time through the loop. Now we have a new player. We have Dave. All right, and so third time through the loop, set name to Dave. check to see, does Dave equal the name that is at item 1 of player? It does not. Okay, so we skip the if and we move to the else. All right, so what we want to do is append Dave to the list. There we go. Dave is appended to the list. And now we want to display the length of player. Okay, now the list is 2. Okay, but still we're on the third iteration here. Okay. All right, fourth time through the loop. Dave plays again. If name, which is now Dave, equals the name at the first item of player, display the length of player. Okay, it doesn't. It's Sam. Sam is still there. Sam was the first name added to the list, and Sam will always be the name at item 1 of the list. Okay, so then we move here. We're going to append player name. We're going to append Dave again. Okay, and this time we're going to display a new length. Now the length is 3. And last but not least, fifth time through the loop, we are going to check and see. Now this time it's Sam again. All right, and so Sam is player 5, fifth time through the loop, set name to Sam. If Sam equals what is at item 1 of player, which it does this time, so last time through we go through the if, and that is true, we're going to display the length of player. All right, and the length of player is 3. All right, so interesting little exercise. You might see something similar as you move through your exam practice. All right, one more example of lists with pseudocode as you might see them on the APCSP exam. This one won't be quite as complex because this one is just a simple selection. If something is true, we're going to select one thing, and if it's not, we'll select another. So this one, we're not iterating through a loop. But again, remember, anytime you're looping through a series of instructions and something is changing, I highly recommend making a way to track those variables so that you can see what's going on. All right, so bringing up again this concept of modular arithmetic. Okay, I'm just going to emphasize that one right there. Remember that this is when we want to know the remainder of a division problem. How many full times can it go through into that dividend, but what is the remainder? Okay, so that's the important part. All right, so here we're checking to see if the length of some list, remember that's a number. Whatever the length of the list is, that's a value. We're checking to see if the length of the list, that quantity, divided by 2 equals 0. Well, that's interesting. So I'm just going to come up with a hypothetical value. What if the list had 13 items? Okay, and if I try to divide 13 by 2, I'm going to come up with 12, and I'm going to have a remainder 1. Okay, so 13 mod 2 equals 1. How about 20? What if there are 20 items? Okay, 20 divided by 2, that's easy. That's 10, and there's a 0 remainder. Oh, so that would be a situation where this would be true, and we'd do this right here. Okay, well, if you can kind of generalize and see, oh, well, any odd number that I'm going to try is going to have a remainder of 1, and any even number that I try is going to have a remainder of 0, right? That makes sense, right? You always want to try some special cases, and if you're talking about odd and even, you would always want to check 0. Right? What about 0? What if I try to take 0 and divide by 2? Well, I can't, but the answer is 0, right? I mean, 2 does not go into 0, but 0 divided by 2 does give us an answer of 0. All right, so that just tells us that even numbers are going to give us a remainder of 0 when we try to divide them by 2. Okay, so we can kind of generalize that now. So the question is, what would be an appropriate way to replace either this one, or preferably both? If you're going to come up with one, you might as well come up with the other, right? So some missing output. So this is something we're going to see on the screen. It's going to be probably some sort of a text string. All right, so if it's true that the length of the list divided by 2 equals 0, then it must have an even number of items in the list. All right, and you would probably say something such as, your list has an even number of items, right? That would be an appropriate thing to say there. So that would be an appropriate display. And then, of course, over here, this would be missing output 2 would be appropriate to say your list must have an odd number of items or something. Okay? That's just an example of what the missing output could be for those two things. And that's another example of what you might see with a list on the APCSP exam.
Hey everyone, it's Mr. Levin again. This time I'm back with a video about lists in pseudocode. So of course, every good programming language has to have lists, and pseudocode is no exception. So let's see how lists are implemented in the pseudocode programming language. So now that we've seen some of the lists in Scratch, we're going to dig into the pseudocode list operations that you will be using and seeing in the AP pseudocode reference sheet. So the first examples that we're going to want to look at are creating a list. And you'll see that this creates a new list that contains values, value 1, value 2, value 3. You're going to use the arrow to assign the list to a variable. Now this variable says a list, but you could call it anything you want. And then you can put either 0 or as many values as you want on this list separated by commas. The second way that you'll see a list created could be just a blank list. And in this case, you'll put empty square brackets and then use the arrow to assign them to a list. You can also assign a copy of one list to another list. In this example, A list is getting assigned a copy of B list. And then when we want to reference one of the items, one of the elements that's on that list, you're going to use square brackets again and a number, or what's called an index, to reference that particular item. So let's see an example of this. So this line would create a list, and when we go through this example, I'm going to ask you to use a piece of paper, and you should go ahead and pause the video right now if you need to, because when you're doing these kind of questions on the AP exam, you absolutely are going to need to take scratch notes on a piece of paper. It's very difficult to keep track of code, especially with a list, without writing everything down. So I'll have my piece of paper over here as I go through the problem and explain it, and then I want you to, on your own piece of paper, be writing these things down. Okay, so first we create a list that has 3 words on it: apple, banana, orange. Our next line is going to assign that list to a new variable called a list. So now a list is also a copy of this list. And then we're going to just display the item at position 2 on a list. And so we know that a list is the same as list 1. And so what we're going to do is we're going to count over 1, 2, and so this should display banana. Now you'll see in block code, this is going to be the same operations. And then what would be displayed by this, hopefully your prediction was correct, it will display banana. So here are some more complex or intricate ways of working with lists. First we have, you can actually pull an item off the list and assign it to a variable in the same step. So this would take item I from the list and assign it to a variable x. We can do the opposite operation, where we assign the value of x to a position in the list. Here we're taking a value from one list, actually the item at position j on a list, and assigning it to position I on the same list. So this will actually copy the value from j and put it into position I. It's important to remember in this case, though, that it's not swapping the two values. It's just assigning the value from j to I. So now we'll have two values that are the same. And then this is the first command that we've seen, or the first procedure for lists, which is called insert. And so insert is a procedure with 3 parameters. The first parameter is the list that we're inserting into. The second parameter is the position where we're going to insert a value. And then the third parameter is the value that we're inserting. And so what this actually does is it inserts the value into the list at position I, and then it shifts any items that were at I or further down, it shifts them down the list, and the length of this list is increased by 1. So let's see what that looks like. Again, we'll start with our list of apple, banana, orange. We can take the word apple and save it into a variable called x. We can assign position 1 the word pear, so this actually erases apple here and puts the word pear. So now our list is pear, banana, orange. Now this one is a little more complex, so make sure you're writing this down. We're going to be taking the value at position 2, banana, and assigning it into position 3, which was orange. So at this point, our list should read pear, banana, banana. And then finally, we're going to insert into a list at position 1 the value that was in x. Do you remember which fruit was in variable x? Hopefully you wrote it down and you remember that this is apple. And so by inserting at position 1, remember everything gets pushed down. And so our list should now read apple, pear, banana, banana. This is the same code in the block-based language. And what will a list contain now? Make sure you have written down what you think should be in the list in the very end. And hopefully you should have apple, pear, banana, banana. Finally, our last set of operations to work with lists. These are the ones that are very similar to the types of commands you're going to see in a standard programming language, a high-level programming language like Java. So here we have append. Append is a procedure with 2 parameters. It takes a list and a value. And append is somewhat like insert, but this just adds the value at the end of the list. Remove. Remove takes a list and a position. Now keep in mind, this is not the value that we're removing, it's the index of the value that we're removing. So if this says 1, then we're going to remove the first item from the list and all of the other values on the list move down. So this will actually shrink our list. Length, it just takes 1 parameter of the list and it just tells us the number of items that are on that list. So if there are 3 words on the list, then length returns the number 3. And then finally, this is a for each loop. A for each loop is a special type of iteration that can only be used on lists. And what it does is it repeats the block of statements inside of this for each loop, assigning every item on the list to this variable item. So let's have a look at how we might use these with our fruit list. So we have a list, apple, banana, orange. Let's add the word peach to the end, so append peach onto the end. Let's remove item 2 from the list. Okay, and remember that anything that came after position 2 will now move down and the list gets shorter, so we should have apple, orange, peach at this point. Then we're going to display the length of the list. Remember there were how many items were on that list. And then finally we're going to use our for each loop to go through and display all the items on the list. So this is what our code would look like in block code. So the question is, what would be displayed? Remember, the first thing that gets displayed is the length of a list. And first we had 3 items, then we added 1, we had 4, but then we removed 1, and so this should say 3. And then we actually went through each item on that list and displayed them one after the other. And so we should see first a 3, then apple, then orange, then peach, right? Because banana got removed and orange and peach moved down. 3, apple, orange, peach. Hopefully you got all of those correct. Feel free to go back and practice on your own, and then there are lots of practice problems for you working with lists as you move forward in the course.